Okay, today I'm recording this a little earlier than class because I'm going to upload it later to the blog so that you can review the examples and then work on the assignment when you have time. We've talked about the surface area and volume. Last week we just learned all the basic formulas for surface area and volume, which are included in your booklet on page 28 for surface area and 30 for volume. And on Friday, we just ran through some really basic examples. I'll just flip to this page. They were really basic examples of they gave you the shape, you figured out the volume, you figured out surface area. So not a lot of thinking involved, just applying a formula. So today we're actually going to do a little more thinking. We're going to talk about irregular shapes, similar to those irregular shapes that we talked about with area and perimeter. So it says in lesson 3, you found the area of irregular shapes by using the formulas for shapes you know and adjusting them for the given irregular shape. You may have added areas, we call that composite shapes, and going backward, those were shapes like the L-shaped living room, where we had to find the areas of 2 rectangles and place them together. Or we talked about shaded areas, where we subtracted pieces out, or we were only interested in perhaps half of a circle, so we had to find a fraction of a regular area. All of these skills can be applied to 3D shapes as well. So that's something to think about, right? All the little tricks that you learned to find irregular shapes in perimeter and area, we can apply these for 3-dimensional shapes as well. Let's take a look at this first one. The following shape is a grain silo. So for those of you who've never seen these, these are huge, usually circular structures in the middle of prairies, and they were used to store grain, things like wheat and oats. It stores grain in a dry place until needed or sold by the farmer. It is made up of a cylinder with a cone. Calculate the volume of this composite shape. So you can see that means we have to find the volume of a cylinder, because we want to know how much grain can go inside, so that's volume. And then volume of a cone. And guess what? Add them up, right? Similar to how we did volumes of the areas. So I'm going to refer back to page 30 for my volume formulas. And the volume of a cylinder is pi r squared h. I'm just going to record my formula here, pi r squared h. And volume of a cone is a third of pi r squared h. Notice how the formulas are almost identical, so that must mean that 3 cones fit into a cylinder. Okay, well this is h for the cylinder. That's the diameter, so that means the radius is 10. All right, so volume equals pi 10 squared times 35. And I'm going to put that all into my calculator. And I get 10995.57 meters squared. And then the volume of the cone, what do I need? I need r squared h again, but this time the height of my cone is 8, but the radius is the same as the cylinder, right? It has the same radius if it's right on top. So the radius is 10. So that's 1 divided by 3, that's what 1 over 3 means, times pi times 10 squared times 8. Remember the brackets mean times? Okay, and I get 837.76 meters squared. Okay, so now total area. Okay, add that and that. And I'm going to get 10 995.57 and 837.76. And don't forget your units. It would be meters squared. Okay, so that's how we handle quite a complex shape, right? You just have to recognize the shapes you see and use the appropriate formulas. Now, once again, just like our assignment and our exercise and lesson that we did with perimeter and area, we're not going to ask you obscure shapes that there's no way you could find the volume or surface area of. They will be the regular shapes that you're used to. Example 2, shaded volume. So shaded, remember shading means probably we're going to have to do some subtraction. A company manufactures cement sewer pipe. So this is what goes underneath our ground and runs our sewer system. The pipes have a thickness of 4 inches and the hollow portion has a diameter of 36 inches. The pipes are sold in 20-foot lengths. Calculate the volume of cement required to manufacture one pipe. So let's take a look. So there in this picture, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, kind of 10 complete pipes, but they're all stacked in one another. So let's just take a look at one pipe. So one pipe. So I have this. This is what they mean. So they have a thickness of 4 inches. So from here to here is 4 inches, right? From here to here, 4 inches. Oops. I think I kind of made things a bit worse there. Okay. Actually, you know what? I'm going to redo this. I'm going to really explode my pipe. I'm going to draw it super big. And again, you guys know. Okay, so this is 4 inches. And this would be 4 inches too, right? The hollow portion has a diameter of 36, right? Diameter equals 36. The pipes are sold in 20-foot lengths. Calculate the volume of cement required to manufacture one pipe. So all I want is, I just want the volume of the shaded part. Now, remember in our previous lesson, how did I find the volume of the shaded part? The volume of the large shape, subtract the volume of the small shape. Usually the volume of the outside shape, subtract the inside shape. So that means volume of large circle, subtract volume of small circle. Okay, so volume of a circle, I'm referring to a sphere, I should say. Or I guess I should say the volume of the small. Hang on a sec here. And then this thing has another end on it, right? I kind of drew that really odd. I guess if I think this this will be, sorry about that, it's going to be a cylinder, right? Because they're three-dimensional, so a three-dimensional circle is sort of like a cylinder because it has height to it. So I'm going to take the volume of the large cylinder and take out the volume of the small cylinder. So volume of a cylinder, we just had that one above, pi r squared h. Okay. So the large cylinder is pi times, well, let's see. The radius of the large circle is going to be half the diameter. So the diameter of the large circle, I'm going to put this maybe in another color. Diameter of large opening 36 and 4 is 44. So the radius equals 22. And this radius is going to equal 18. So from here to here is 44. 4 plus 36 is 40, plus another 4 is 44. So all the way across the large cylinder opening is 44. So halfway is 22. So pi times 22 squared times 20, because that's how long they are. Or if I upended it, that would be its height. And this is pi times 18 squared times 20. Okay, so I've got two volumes I'm finding. So volume of large is, okay, I'm going to just punch that into my calculator. So pi times 22 squared times 20 is 3040.62. And then I have volume of small. I'm going to put this in, pi times 18 squared times 20. And that's 20357.52. And if I subtract these two, 30410.62 subtract 20357.52. I get 10,053.1 feet squared. Okay, so that would be the answer. So these are cylindrical, like hollow cylinders, but they're hollow because we end up subtracting out that middle piece. So if I just was looking at it face on, a circle, which I wrote initially, but a circle with height is a cylinder. Okay, let's look at example 3, and I'll post the notes, of course. So find the surface area of this container that has a bottom but no lid. Okay, so surface area of a cylinder. So we're going to look at our surface area formulas. And surface area are the tougher ones, right? Because they have all those pieces. But if you look at the surface area formula, the surface area has 2 pi r h refers to the surface area of the wall, and 2 pi r squared, so the bottom or the top is a circle, right? So 2 of them is the top or the bottom. So the whole surface area formula for this one, we have 2 pi r h because we need the wall, but we only need one of the circles, right? So we're going to adjust cylinder with no top. Our formula becomes 2 pi r h plus pi r squared. So I'm leaving the 2 off. I don't need 2 of them. I just need 1. So this is the wall. This is the bottom circle. We don't need the top circle. All right, so this of course is h. My radius must be 1.5 if my diameter is 3. So now this becomes 2 pi times 1.5 times 4 plus pi times 1.5 squared. Okay, and I just put this all in my calculator in one step. So I only have to round once. So whenever you can do that, really try and do that. So that was inches squared. You know what? I just remembered I did something wrong on the previous page, of course. That volume is supposed to be cubed. Cubed. Sorry about that. Yikes. a horrible mistake. Okay. Okay, so example 4. We're calculating the surface area of the following box used as a mold to make triangular chocolate treats. It has a bottom but no top. The peak of the end of the triangle is 3.12 centimeters. So this is obviously the height, right? So this is a triangular, I know it looks odd, but this would be a triangular prism, right? So surface area, it has a bottom but no top. So surface area of a triangular prism, just like a triangle with. So let's take a look at this. The ends are B times H, so those are the ends, and the sides are L times A plus B plus C. So let's take a look at this. So the surface area, I think we're going to find the surface area of the whole triangular prism, and then we're actually going to have to subtract a triangle out, right? Surface area of the triangle prism, subtract the area of one triangle. Okay, so what is the surface area of the triangular prism? That formula is B times H plus L, A plus B plus C. Okay, so remember the surface area is a collection of all the areas. So let's see what we have here. This is the base. This would be the L. Okay. These are the A's and C's. A, C, which are the same. This would be the B. And this is the H. Okay. So the surface area of the rectangle prism equals B times H, 5 times 3.12 plus L, 4.5, bracket, A plus B plus C. Okay, so I'm just finding the surface area of the whole rectangular prism, but I don't need this lid. I need the bottom one, but not the top. So I'm just going to subtract the area of this one triangle, and it's just a flat triangle. It's just a flat piece, which is what surface area is. It's a collection of all the flat pieces. So I have to subtract off B times H divided by 2. So let's see what this equals. 5 times 3.12 plus 4.5 bracket 4 plus 5 plus 4, close bracket. And I get 74.1 centimeters squared. And then the bottom, I'm going to get 5 times 3.12 divided by 2, and I get 7.8 centimeters squared. So total surface area, 74.1. So that gives me all the sides. Subtract out that one side. .3 centimeters squared. Okay, guys. That was a very strange one. I mean, there are also other ways you can do these, but basically, and you'll have a chance to practice. Now, this is a really tough assignment in that it's going to require you to do a lot of thinking. It goes on to the next page, so there's lots and lots going on here. So take your time. There's more than one approach to each problem. But just, yeah, try your best, and I will post detailed answers in the next by tomorrow. Okay, so I'll post my notes and I will give you time to work on this, and I'll give you a bit more time tomorrow.